Okay, so today we're going to dive into something uh, pretty amazing, right? We're talking AI, obviously. That's what we do here. But like cutting edge AI, the
Mhm.
kind of stuff that, could like revolutionize everything.
Oh, yeah, absolutely. We're going deep on mixture of experts models, MoEs.
Moses, right.
Mhm.
I mean, think about it. It's like having, I don't know, like a team of like super specialized AI experts all working together, right?
Yeah, each one like a specialist in their field tackling different aspects of a problem.
Exactly. And like, together they can solve these incredibly complex things way beyond what any single AI could do.
Think personalized medicine, tailored specifically to your DNA,
Yeah.
or like robots that can actually learn and adapt like in real time.
Ooh, okay, yeah, that's some next level stuff. And we've got some really exciting stuff to talk about today. There's this company, DeepSeek, and they're doing some seriously cool work with MoEs.
DeepSeek, yeah, they're making waves. You might have heard of their Flash MLA project.
Oh yeah, Flash MLA, that one blew up on GitHub, right? Like tons of stars, everyone was talking about it.
Over 7,000 stars. It was huge. And now they've released this new library called DeepEP, specifically designed to like supercharge MoEs.
DeepEPs. Okay, so that's what we're diving into today.
Exactly. DeepEP is all about making these MoE models faster, more efficient, basically unlocking their full potential.
So before we get into the nitty-gritty, remind me again, why are these MoE models like such a big deal?
Well, think of it this way. With traditional AI models, it's like having one, really smart person trying to do everything. But MoEs are different.
Like a team instead of just one person.
Exactly. It's like having a team of specialists, each with their own expertise working together, so you can tackle way more complex problems, things that were just impossible before.
Got it. So more brains, more power. But then doesn't that create like a communication problem? Like
Yeah.
all these different AI experts need to talk to each other, right?
Exactly. And that's where things can get tricky.
Hmm. There's always a catch.
Right. This communication between the experts, it's called all-to-all communication. And it can be a real bottleneck, especially when you're dealing with massive amounts of data.
A bottleneck, so it slows everything down.
Right.
Okay, yeah, that makes sense. So how does DeepEP help with that?
Imagine like 4 GPUs, each one representing one of these AI specialists, working on their part of the problem. They need to constantly share information, data, insights to get the job done.
Right, like passing notes in a super smart study group.
Exactly. And DeepEP basically streamlines this whole communication process, optimizes it both within and between servers, even across different physical locations.
Wow, so it's like creating a super efficient communication network for all these AI experts.
Precisely. And it uses some really clever tech to achieve this, like NVLink, for example.
NVLink, I've heard of that. It's like a super fast connection, right?
Yeah, it's designed specifically for communication between GPUs. Think of it like a dedicated highway for data, ensures everything moves super quickly.
Love that analogy. Like a data superhighway.
Mhm.
And then there's RDMA, right? That helps with like direct memory access between systems.
Exactly. RDMA bypasses a lot of the usual software overhead, allowing for like super fast data transfers. So like, while one GPU is sending data to another, it can simultaneously be receiving information from a third one.
Ugh. No, so it's like this like perfectly choreographed data dance,
Mm.
all these GPUs working together seamlessly. But like, how does this actually translate to training and using these MoE models?
Great question. So DeepEP has these things called kernels. You can think of them as like specialized tools for different tasks within the MoE framework.
Kernels.
Yeah.
Okay, so what kind of kernels are we talking about here?
Well, there are two main types. First, you have high-throughput kernels, which are designed for like super fast data processing during training. Imagine like quickly filling up a giant swimming pool with information.
Okay, so high throughput is all about speed, right? Getting through massive amounts of data quickly.
Exactly. And then you have low-latency kernels, which prioritize speed during inference. Think of how quickly like each word pops up when you're using a chatbot, for example.
So if I'm building a chatbot, I'd want those low latency kernels to make the conversation feel snappy and natural.
Precisely. And for a research project like crunching massive data sets, you might prioritize those high throughput kernels to get through all that data as quickly as possible.
Got it. So different kernels for different needs. This is making a lot more sense now, but I mean, all this speed and efficiency, it must come at a cost, right? Like in terms of computing power and resources.
Well, that's the really amazing part. DeepEP actually supports FP8, which is a super efficient way of doing calculations. Instead of using full high precision numbers, FP8 is like a shorthand language for computers.
FP8, so it's like a shortcut that saves time and energy.
Exactly. It's incredibly resource efficient, meaning you can run complex AI models on less powerful hardware, potentially even like on your own computer.
Whoa, that's a game changer. So does this mean, like, researchers and companies with limited budgets can now access these powerful MoE models?
Absolutely. It democratizes access to these like cutting edge technologies. And there's another mind-blowing aspect. DeepSeek can actually overlap computation and communication.
Wait, what? How does that work?
So while a GPU is waiting for data from one source, it can be processing information from another. It's like being able to, I don't know, cook dinner while simultaneously doing laundry, something I wish I could do.
Multitasking on a whole other level.
Yeah.
Okay, this is seriously impressive. No wonder the online AI community is buzzing about DeepEP.
Yeah, people are like praising DeepSeek's ability to tackle these complex challenges. The combination of, cutting-edge hardware support and innovative techniques like FP8 is generating a lot of excitement.
Do you have any examples of, like, what people are saying?
Oh, yeah. I saw one comment that said, DeepSeek's optimization of the hybrid expert model is remarkable, and another that was just like, more CDA kernels. Another outstanding achievement.
So, like, what does this all mean for the future of AI? It sounds like DeepSeek could be, like, a major catalyst for progress.
Absolutely. Imagine like faster, more efficient MoE models being used to, develop truly personalized medicine or create robots that can learn and adapt to complex environments.
Or design virtual assistants that are, like, indistinguishable from humans.
Exactly. We're talking about the potential to solve some of humanity's biggest challenges, in healthcare, climate change, you name it.
It's like we're on the cusp of a new era of AI, where these incredible capabilities are becoming more accessible and impactful than ever before.
And that brings us to an important question for you, the listener. How might these advancements in MoE technology reshape the world around you? What possibilities does it unlock for your work, your hobbies, or even, like, your everyday life?
That's definitely something worth pondering as we enter this exciting new frontier of AI. And as always, keep exploring, keep learning, and keep pushing the boundaries of what's possible. Thanks for tuning in.
Thanks for having me. It was great to dive into this with you.